Hi friends, welcome to this channel. Here we are going to look at a tree problem. It's clone inner tree. This problem and this several problem like problem 133, problem 138, problem 1490, problem 1485, they are all clone something. Actually, the idea would be the same. So here the data structure used is a dictionary or hash map, if you like. So then the other ingredient will be some traversal, right? So as to traversal, typically you have recursive ones, right? Recursive or iterative. So here in this video, in order to understand the details, I'm going to write in terms of iterative format. So with that said, let's look at this problem statement. So basically, we are given the root of an inner tree. So we want to return a deep copy of the tree. So here we notice that there's a class definition in the node to have two fields, value and children. So children is either null or a list, right? So we want to return the corresponding, so let's see, I think we need to return the corresponding root, right? So here the depth of the inner tree is less than or equal to 1000, and the total number of nodes is in between 0 and 10 to the power 4. So these two constraints are giving the problem size upper bound, right? So with that said, we are actually ready to do the code. So here actually you can imagine, so the main idea is like this. So you do traversal in the original tree, then you map all the corresponding operations into the corresponding values in the dictionary. So there's a concept in mathematics called homomorphism. So essentially it's a similar thing here. So let me write the code, and then you can have some digest of this concept, right? So here first, because it's possible that the root represents a null tree, so because the total number of nodes can be 0, so we can first do a test base case check. So if not root, so we are going to return, or you can return a null value if you like. So that's also demonstrates the power of null keywords. Then we are going to make a dictionary, right? And then first we are going to map the root, because we have done this if check. Now the root is not null, so we can actually make a node. This is a new node instance. The value would be the root value, right? So now we are going to do the standard traversal. So here I'm going to use depth first based traversal, right? So here S I mean a stack, right? So now the things will be very routine. Well, S, so you can get the node as S pop, right? So then we're going to check the neighbors. So for neighbor in nodes, so we can have this children field, right? So here we want to check if neighbor not visited yet, not in D, right? So you can understand this D is a strengthened version of set, because if it's a set, we can avoid repetition. But here with a dictionary, not only we can have a property of the set, we also have the corresponding values. So those values, you can regard it as a mirror image of the node, right? So if this is not the case, so we are going to first map the neighbor into the corresponding new node, that is neighbor value. So then we are going to append this neighbor to the stack, and then afterwards, so if you look at each neighbor, so you're going to do the same thing in the parallel universe, right? So basically you can do D node, so it's children. So this is legitimate because D node, it will be a new node object. So node object has two fields. One is value and one is children, right? So then because children is a list, so we need to use append, right? So what we need to append is nothing but the neighbor. So this is legitimate because we have already set this to be mapped to the mirror image, right? So with that done, I guess we are ready to return the node, right? So before we make a further comment, let me first do a test. So here you must return a copy of a given reference to the clone. Let me see where's the problem. So here, if not root, so we're going to return. Then we have d. You have the root is node root value, right? And then s. So we have this. And then for neighbor in node children. Then if neighbor not in d, so we d neighbor equals node neighbor value. Then s append this one. Then children append the neighbor. So what we want to return actually is the root. Now let me run it. Yeah, it passes the two test cases. So now let's look at the generic case. Yeah, it passes all the cases. So let me again to summarize the idea. So here we are using the data structure, dictionary or hash map, and then we do traversal, and then we do the same thing using this idea similar to homomorphism. So you can understand that this is doing exactly the same thing. The thing here actually in operation or some other things in mathematics. So doing exactly the same thing or operation in a parallel universe, right? So this is the plain English explanation. But hopefully this is just some heuristic, and hopefully it will help you digest the idea. As to the code, once you realize the idea, the code is rather straightforward. With that said, I guess that's it for the current video. Thank you for watching.